Hey there, gang. This is lection. This is lecture 4.10, all about transforming linear functions. And so here's the point. First of all, before you get started, everyone needs some colored pencils. They're in the green can over here on the shelf. You're going to need little rulers too. And then pieces of lined graph paper are right here on my desk. Make sure you get one of those strips. So a family of functions is all the functions that have that share similar characteristics. For example, we've been talking mostly about linear functions. And again, a linear function goes at an angle. It's a straight line. It can be up, down. It can be vertical, horizontal, etc. There's no bends or breaks in it. There are other ones. We talked about exponential functions when we looked at the price of Apple stock, quadratic functions, etc. Well, the most basic function in a family of functions is known as the parent function, or I like to call it the mother function. And so if a function is a function of x, the parent function would just be x. And then from this, you would change it. Now, again, if I'm talking about a linear function, think of y equals mx plus b. And the most basic simple linear function would be y equals 1x plus 0, right? It passes through the origin. It's direct variation. The slope is 1. It doesn't get any better than that. What we're going to talk about today is transforming those functions, actually taking a parent function, such as f of x equals x or y equals x, and moving it, making it more steep, moving it up or down. So there are three types of transformations of functions. You've got translations, shifting them up or down, rotations, turning them, and reflections, flipping them over. So let's take a look at these four functions right here. The blue line is the parent function or the mother function. F of x is equal to x. And again, every time I say f of x, that f of x means the output, where x is the input. We also think of it as y equals. Now, if I shift this function up 3, if I translate it up 3, all I'm doing is shifting the y-intercept. It goes from 0 to positive 3. If you shift it down, you translate it down 2. You can see the only thing that's shifting is this point right here. All of these lines, you'll notice, are parallel. They have the same slope. I'm not changing the slope. All I'm doing is changing the y-intercept. And again, that's what's called a translation. This is straight out of the book. As you increase the y-intercept, you shift it up. As you decrease b, the y-intercept, you shift it down. And then it says, hey, let's actually go ahead and try this problem out. It says graph the function f of x is equal to 2x, and the function g of x equals 2x minus 6. And then describe the transformation. Well, wait a minute. If I've got f of x equals 2x, it means it has a slope of 2 or a rise of 2 for every 1 over. And it passes through the point 0, 0. So I plot my little blue line. If I then have the function g of x, 2x minus 6, that means that each one of these points is shifted down 6. And another way to do this is to make a table. You have an x and y table, right? Plug in a value of 0. Plug in 0 here. 0 times 2 is 0. Plug in that same value here. You get 0, and then subtract 6. This point gets shifted down 6 units. So let's describe the transformation. Well, that's simply a translation down 6 units. And that's what it says right there. This is shifted down 6 units. When we think about rotations, what we're talking about is making something steeper. So again, as you increase the slope, you make it steeper. As you decrease the slope, you can see which way it's kind of rotating. So again, here's my blue line, my parent function, my mother function. If you change the slope to 1/2, you make it not as steep. If you increase the slope to 3 or 5, you make it much steeper. So you can think of it as terms. So the next question, of course, is, all right, I've got f of x equals 3x minus 1. I've got g of x, which is 1/2 x minus 1. So you want me to graph those? Okay, I can do that, and then describe the transformation. Well, here's f of x, here's g of x. I've rotated it about the y-intercept right here in -1. So I've rotated it, and it has become less steep. So that's the general idea. I know they're showing you pictures of graphing calculators. I don't know if we're going to get to that this year, but hopefully we'll be doing other things. The last one, of course, is a reflection. And in a reflection, typically you reflect it across the y-axis, but it's actually also reflected across the x-axis. So you can see this point here at 1, 2, when it gets reflected, it, across the y-axis, you could say it gets reflected at -1, 2. That's one way to think. You're flipping it over a line, but you notice it actually also flips vertically as well. So when the slope is multiplied by -1 in this function, the graph is reflected across the y-axis. So when we just take the slope and we flip it across the y-axis. So again, if you go from 2x is here and you make it -2x, all these points flip over the axis right there. And so let's see what that one looks like. All right, I've got 2/3 x plus 2. It's reflected over the y-axis, which means it is now -2/3 x plus 2. Right? It becomes -2/3 x plus 2, and all those points flip. All right, maybe just a couple more problems. Let me take a sip of water, I know. Okay, it says graph f of x equals x, parent function, and then g of x, 2x minus 3. Graph these both, then describe the transformations to go. Well, first of all, you graph them. Let me get my picture out of the way. I'll move it over here. Here's f of x, and the first step is 2x minus 3. What do you have to do? Well, you make the slope much steeper. So you rotate it there, and then you shift it down 3 units. So you went from passing through the point 0, 0 to passing through the point 0, -3. So what did you do? Well, I first of all made it steeper. I rotated it steeper, and then I shifted it down 3 units. Now, of course, no day is complete without a real-world problem. A florist charges $25 for a vase, plus $4.50 for each flower. The total charge for the vase and flowers is given by the function. Oh yeah, f of x equals 450x plus 25. Makes sense. You want 1 flower? It costs $25 plus $4.50. If you want 2 flowers, $25 plus 2 times $4.50. How will the graph change if the vase's cost is raised to $35? Well, if you increase the cost of the vase, the cost will shift up by that difference. So it'll shift up by $10. What if you change the per flower charge from $4.50 to $3? Well, if you do that, you're going to rotate it, and it's not going to be as steep. Right? And that's what this graph down here is showing you. It said, hey, first we shifted it up, but then and that's just raising the cost of the vase. But here in the second scenario, you're saying, well, keep the cost at 25, just make it less expensive per flower. You can see this green line has a shallower slope. So that's what they want you to do. I've given you this practice sheet. I want you to try it. I know you got lots of work. You're doing great. I'm really proud of you. And then you've got a few more problems here. And of course, you can pause this video anytime, because here are the solutions. 1 through 3, 4, and 5.